Today's adventure in chromatography deals with the EPC from one of our 6890 GCs. And there's the EPC. This is I've removed the unit. Had to do this in order to get the part number. Finding the part number for the valve is not it. It was difficult for me. On this particular unit, the air has been malfunctioning. It's not been letting enough air to the FID detector. Replacement part number for the valve, for this valve, is G1531-60720 and runs about $250 US in 2016. All right. The other thing I'm going to do is I'm going to replace some of the O-rings. So let's see, are the O-rings visible? So here we have some of these O-rings. The O-ring part number is 5180-4181, and it runs $16 US in 2016. If I'm going to be taking this apart, I'm going to replace the O-rings while I'm doing it. Okay. And I guess it's time to take things apart. Alright, so this is a T10 screw. I'm going to undo this. And let's see what happens. Okay, so screw comes off, and the circuit board has two supports, and you have to be careful. Circuit board doesn't come off of this back support easily, so what I'm going to do is unplug these valves and label them as I disconnect them. So that's what I'm going to do next. Alright, what seems to work for me is to take the blunt end of the long needle nose, slide it in, there's a recess, and just work it out. Okay, and then that comes out, and we can do the same for other valve that gave problems. Slide and just work it out. Alright. So now we have these three valves. Okay. So let's say I made and marked this guy, so it's for 1. This is 2, and air is going to be the one that gets replaced. Now let's see if there's some way of getting this off of here. Alright, so the board must slide in here, and what you need to do is, let's see, lift and gently, because the last thing you want to do is go breaking supports. Okay, and then it comes and exposes itself. Alright. Alright. Okay, this valve is held in by this. Let me take this off. See if it's also a T10. Yes. Okay. So let me take this, turn this, and see if the valve comes out. So I'm going to loosen this and remove it. So this one is, let's say, about the same length, and now comes the interesting. So here, this is the valve that's going to be replaced, and it's very loose after that, and it just comes out. So we have some, okay, we have 2 O-rings here and 3 O-rings here, so that's 5 O-rings to replace out of the pack of 12. Here's a close-up of the 2 of the O-rings, and I've pried with a small flat screwdriver 1 O-ring off, and then just lightly laid it back. But on the one that I haven't removed yet, you can see there's a little bit of sort of debris. Let's see if I can zoom in and see if it focuses. It's not going to focus. Alright. Okay. Anyway, so I'm going to remove that and then put in new O-rings. This is as close as I can focus. There seems to be some white junk on just the inside diameter of the O-ring on both sides. So it's, let's see, get this here. So it's around here. Let's see if I can, and then flip it on the other side. It's just on the inside there. Alright, so maybe that was what was partially obstructing the air valve, preventing full flow, because the orifice is only 0.010 of an inch, and so that stuff could have plugged things up. So, the thing what I'm going to do is just replace these 2 O-rings and reinstall the valve, the new valve, and see what happens. I used a Q-tip with some 50-50 ethanol water, wipe down the surface on this side of the manifold, this side here, and dried it with another Q-tip before pressing in the new O-rings. Now I'm going to reinstall a new valve. So I guess I'm going to install a new valve. Alright, new valve is on the bottom, old valve is on the top, and sorry for the shaking, but so there's a screen on the old valve. There's a screen here and a screen here. On the new one, there's just a screen here, and then this is on the output side. I guess the idea as well, no need to have a screen on the outside, on the output side. So both new valves are lacking that second screen. So I'm going to install a new valve, and then we can see what installation should be pretty straightforward. There are 2 plastic projections that, sorry for the shaking, 2 plastic projections and then 2 holes for the O-ring. So if we look at that, alright, so let's see, this for here and for here is where the projections will, this manifold will sit over the 2 plastic projections here and here. Okay? And then the screw will force the O-rings down into its proper cavity, hopefully. The valve is inserted, and the screw is tightened to something reasonable. So there's no torque spec that I could find, so I just kind of make it nice and snug. Okay, so printed circuit board goes into the slot here in this plastic support. Alright, hole should line up here. Alright, and then this corner just rests on the by the support. In fact, it doesn't even rest. It's just sort of to keep the proper orientation. There are some other parts that I need to order for the system, and I'll go over that. There's a hypothesis as to what went wrong. Alright, and now this screw is in place. And so it's going to be a couple of days before I can test this unit. Just got to wait for some parts to come in to add protection to this valve. Oh, well, let's see. And then as far as this, plugging it back in, it's pretty simple. It's just, let's see. Let me zoom out. It's just snap, snap, snap. So, old valves say Hewlett-Packard on it. This new one says Agilent. And so next week we'll test the EPC, see how well it works. This is a can't hurt tangent in the repair of the EPC unit for one of the 6890 GC FIDs. So the FID's air is being fed by this zero air generator from Wattman, and the valve that failed had these fine particulates on and it was the air valve. So what I'm going to do is I'm going to install a couple of filters. So these are disposable filters. This is a 90 micron, this is a 40 micron, quarter-inch NPT fitting. So this is the coupling. And because the tubing up here is 3/16, all right, poor choice 2 decades ago, all right. So what I have is 3/16 NPT, a quarter-inch NPT connector, filter, all right, 90 micron, 40 micron, and then the other connector. And what I'm going to do is I am going to cut the line here and install this. Alright, so this is with the filters installed. Alright, I'm going to zoom in, and I've reignited the FIDs. Alright, so this is in the air supply. And the rationale is that the one valve that failed had these particulates, and it could be that, and our working hypothesis is that on this zero air generator, which is getting to be 20 years old, that the catalyst is on a substrate, and perhaps the substrate is slightly deteriorating. Alright, so in order to hopefully catch any deteriorating particles, we're going to have these filters. These filters run less than $5 a piece, and if their job is to catch stuff, and if it turns out in the future that the airflow is insufficient due to these being plugged up, well, that's okay. We'll just replace them, and it's better to replace a set of $10 filters than a $250 valve, or 3 $250 valves, or a $3,500 EPC. GC on the left is the one in which the EPC is going to be reinstalled, and since air, hydrogen, and nitrogen are all from a common source to these three GCs, I'm going to cut the flow at the tanks. I'm not going to be able to show the disassembly of the EPC out of the GC. We'll just have to work in reverse. So this is the back side of the EPC, and there's this group of 3 O-rings here. Right? This plate here holds, forms the connection with the O-rings, and that screw is with the lock washer is a 4 millimeter by 12 millimeter, and you can see its projection is about the same as the orientation pin projection. So let me put that together. Alright, so there's a guide here, and this goes into on the plastic, slides this way. The cable goes back to its connector here. Unit is unplugged. So I want to make sure. Unit's unplugged. No gas is flowing. And then this guy slides, and this is where the trick comes in. Slides. I'm going to work on that. It's tricky. Definitely tricky. Let me get a close-up of this. Alright, so there's a notch here. Right. Plastic, chassis, aluminum. Right. So that slides in there. Right. We haven't put the plate against the O-rings yet. And there's a Torx 15 screw right here, which is going to hold it, and the easiest way to get it is to lift the lid, have your Torx driver come in and tighten it this way. I've taken off the lid. It used to be here. I'll show you how to take the lid off. Right over here, there's a open slot. So all you have to do is work its way up, and you can take the lid off. Lid pops off like that. All right. So anyway, all right. Torque screws loosened again. All right. So get some space here. This is to get the wire, the tubing, go through here, and then have it go through this slot. And now we will slide this and fasten this. So let me move this back. 12 millimeters was a little long for the screw. It was bottoming out, so I went to a bolt that's a 10 millimeter long bolt, and just to make life interesting, so I have a round washer and a lock washer. So snug that up, establish the routing for the tubing. And I'll put the lid back on and put the sheet metal back on. Alright, so the back end sheet metal is slightly modified from the factory because we have this hot exhaust deflector. And anyway, so the tab goes up, and you want to stick that there and tighten it. So let me do that. Then we have this top piece. It has notches that fit in the different protrusions. So this goes on top. This little tab fits in up there. There's a tab here, and then there's a screw up here. Then we have a plastic top piece that has 2 locking tabs. So this guy goes in here. And then I'm going to snap it down. Okay, now it's snapped down. And then the last piece is the lid. Alright, so here we have the lid. And it's a simple matter. There's a hole here. It goes in there. We have the slot. I give it a gentle nudge. And that's how we get the lid back on. Alright. So, what's left now is to re-establish the gas lines. And for that, I'm going to make a modification, and this is the rationale. Right. These are stainless steel fittings. All of my gas supply lines are copper. Right. They're like, alright, this is plugged off, they're like this. And what happens is that copper into the stainless steel tends to deform too much and tends to stick. So what I'm going to do is I am going to add some 1/8" extensions, maybe 5 centimeters long, and then make the gas connections to this. Alright, so extensions first. And this is the back of the GC. Alright. So we have our 3 extensions. 1, 2, 3. For air, hydrogen, and nitrogen. And then we're going to have to make re-establish a connection for the helium. Alright, so here we have our 3 gas connections hooked up for the FID. We have the helium. We still have the split exhaust to take care of here. And so I've plugged in, powered on. I'm going to power on the instrument, and I'm going to see if we get any sort of response on the air control. Alright, so I've turned on the power. The status is a bunch of flows are not on yet. Alright, so the oven I have off. So I'm going to go to the front detector and turn the temperature on to 25. Alright, and airflow I'm going to turn on. And we can see that, it goes to some value. Alright. Now let me change the value within 300 and see if it drops down. Alright. Okay. So now next we have to verify. That's why the temperature is low, because I'm going to get a flow meter and verify that we have some sort of decent airflow before turning on the other gases. Alright, so I've set the airflow on the FID to 300, and I have an adapter. Alright, this goes into the FID tube. So you can measure the flow, because the tubing goes from here to our little bubble flow meter, which is graduated in 1, 10, and up here is 100 ml. And it's filled with Snoop, so let me get in there. So see that? And so, let's see, let me get a bubble going, and it goes up. Alright, and so then you just use your smartphone and you check to see what the flow is. See if it's close enough. So, for 300 mLs per minute, for the 100 ml setting, for the 100 ml volume, should be 20 seconds. So let me time it and see how close it is. Alright. Using the smartphone, instead of 20 seconds, came out to 18 3/4. Alright. I think it's close enough for our purposes. We'll just, instead of setting it at 450, we'll set it at 400. And if we want to calibrate it, there is a procedure available. Just Google 6890 EPC calibration, and there's a PDF that Agilent has, and for us it's good enough. So I've turned the heater on for the FID, and I'm going to get the flame going. I got to finish adding the connections for the splits and moving the GC back and getting the hot exhaust oven deflector system hooked up again. Alright, so let me take care of it. Alright, so the GC is moved back and sort of, let's say, reasonable configuration. And then the nice thing about this open gap oven deflector system is, okay, you just kind of get it like that. Alright. That way there's suction here. And the last but not least, the split vent connection. And so that's this. So this is the splitless inlet vent, and this is the septum purge vent, and these make their way to an exhaust hood. So save ourselves some money with the EPC repair by just switching out a valve. Alright, so airflow I've set at 400, and I'm going to run a test overnight to see if it maintains it. I've turned on the detector, FID, so we got hydrogen, air, nitrogen, flame on, and we have an output. Alright, so we'll see how well an overnight run, if it holds this. Otherwise, I can see if we change. So if I go, say, like 385, it goes down. Okay, and if I go back to 400, whoops, 400, it goes back up. Alright, so we'll try the overnight test and see if it maintains airflow of 400. And this is after our overnight test. See how things are. Alright. Airflow. So, detector stayed on. And let's see if the airflow will adjust. So let's take it down to 380. And then let's take it up to 450. let's take it back to 400. Okay, and flame is still on. Looks like the repair worked.